they are lying, and the results will be catastrophic.
They are lying.
We all know how scary climate change is, but what scientists have recently discovered will leave you shocked. Top climatology specialists are deeply divided on how climate change is affecting weather patterns, and it seems that different experts have conflicting ideas about how this effect is manifesting itself. Although many people might link the notable changes in weather patterns over the past few decades to climate change, experts disagree and suggest that the changes may not even be related to it. Australia is one of the major nations that is situated directly in the path of these unpredictable weather fluctuations. For the past few years, the nation has been severely impacted by the infamous La Niña winds, which have led to significant flooding and cooler summers on the east coast of the nation. Let us explain the La Niña weather phenomenon to those of you who may not be familiar with it. The natural climatic cycle known as La Niña plays a significant role in the circulation of cool air over the tropical Pacific Ocean. It is a component of a bigger cycle, with El Niño, which has warmer winds than La Niña, making up the other half. Sea surface temperatures differ between these weather events, and both have opposite effects on both ends of the central and eastern tropical Pacific. The El Niño Southern Oscillation, or ENSO, is the term used to refer to both meteorological phenomena. The impact of La Niña and El Niño on weather patterns can cause heavy tropical downpours and flooding in one area, while simultaneously bringing drought to another, and the cycle changes, even though ENSO's climatic impacts are mostly felt in areas near the tropical Pacific. ENSO is the dominant force causing global interannual climate variability, since these impacts may very likely spread to any region of the world. Southeast Asia, Western America, Australia, and Antarctica are particularly affected by ENSO's impacts on precipitation and temperature change. Australia has seen more La Niña occurrences recently than any of these other locations, and the third consecutive La Niña event brought on the most recent flooding. 3 La Niña episodes in a row are extremely uncommon because they typically occur alternately each year, with warmer El Niño events often coming after a single La Niña. However, other experts and researchers have stated that regardless of how uncommon 3 consecutive La Niña events are, they are neither impossible nor unheard of. Some experts have attributed it to rising surface temperatures, which have varying effects on the frequency and intensity of these climatic events. A series of La Niña episodes that occurred between 1974 and 1976, as well as from 1998 to 2001, has been documented. La Niña is responsible for the rainy and cold weather Australia has had over the past 2 years by bringing colder winds from the eastern and central Pacific that are moving into regions of eastern Australia. The southwest United States and Latin America, on the other hand, have been experiencing severe droughts and dry weather as a result of El Niño events. Moving on, the Intergovernmental Panel on Climate Change, or IPCC, indicated in a report that the Central Pacific's rising temperatures may be to blame for the Central Pacific's increased frequency and intensity of El Niño events during the past 20 to 30 years. Although the association between temperature and ENSO event changes was noted in the paper, it was made clear that this did not necessarily imply that human-induced climate change was to blame for the variation. Using the instrumental record and paleoclimatic proxy evidence, scientists were able to trace the occurrence of these ENSO episodes back thousands of years. These paleoclimatic proxy records are produced by analyzing the growth and evolutionary characteristics of ice cores, tree rings, and sediment deposits in lakes and seas. These records show us the climatic state of the globe during a specific period in the past. According to an analysis of these records, incidents have fluctuated and shown varying amplitudes throughout the past 11,000 years. This informs specialists that there aren't any definite signs that the changes in ENSO events we've observed since the 1950s are unusual or even the product of climate change. Additionally, simulations of climate models used to forecast the future patterns of ENSO occurrences have shown comparable oscillations. This may simply be the way the planet functions, with erratic highs and lows that may not be directly tied to human activity or greenhouse gas production. According to an IPCC analysis, there is no agreement on how greenhouse gas emissions will affect changes in sea surface temperatures over the coming millennia. Whatever the case, one thing is for certain: It is highly likely that over the next few years, rainfall variability across the east-central tropical Pacific will grow dramatically. There is no universal agreement to show 100 accuracies on future weather patterns when it comes to sea surface temperatures and ENSO occurrences, because some models actually do predict some changes, but the primary problem still exists that some models do not indicate any change at all. This issue is also visible in the shifting ice patterns and winds that have had an impact on the growth of ice in and around Antarctica. In fact, specialists have noted that the ice sheet on the eastern Antarctic Peninsula has been expanding since the start of the 21st century. Climate scientists from Canterbury University in New Zealand and the University of Cambridge in the United Kingdom collaborated on a study regarding the matter. The floating ice sheets on the eastern and battered peninsula have risen dramatically between the years 2000 and 2019, according to evidence gathered by both teams. For a more accurate computation and comprehension of the precise expansion of ice conditions around Antarctica, scientists use atmospheric and oceanic data, satellite imagery, and observations going back as long as 60 years. The study focused primarily on a 1,400-kilometer-long peninsula of ice, and combined records indicated that the ice shelf surrounding Antarctica has grown by at least 85% since the early 2000s. The team went on an exhibition to the frozen continent itself in 2019 and discovered that the ice sheets near the coast had significantly advanced since satellite records first started observing them in the early 1960s. Since there have been documented patterns of ice melting in both the North Pole and other areas of the polar ice caps, the expansion of the ice sheets surrounding Antarctica at this point in the 21st century is highly unusual. This is further complicated by the level of contradictory findings, with some experts predicting a large loss of ice from the polar ice caps. Others claim that there may very well be a major gain in ice. One thing that is certain as the century progresses is that sensor events are a very complex idea. One of these factors almost certainly affects ENSO events differently from the others, but it is difficult to say which one. Furthermore, it is difficult to identify a precise pattern given the long-term consequences of ENSO episodes during the past 1,000 years. However, there is still research being done that may provide conclusive insight into how climate change may develop over the next century. If you enjoyed the video, don't forget to subscribe to the channel and leave us a huge thumbs up. Share your theories about future ENSO events in the comments down below. Thanks for watching. See you next time.